Now we wrap up 5.1 with solving equations both with and without a calculator. Anytime you're solving without a calculator, you'll be using your unit circle. So it's important to have those down already. And let's start with the tangent squared here. It'd be nice if there was just a tangent, so we will take the square root of both sides and we will get that the tangent of x equals, now when I take the square root, I have two possible outcomes, either positive or negative 1. Therefore, I've got several different places to look at on my unit circle. So for a visual, I have a slope of positive 1 or of negative 1. And those angles, of course, are at pi over 4s. So we have positive 1 at both pi over 4 and at 5 pi over 4. And we have a slope of negative 1 over here at 3 pi over 4 and also at 7 pi over 4. So we have 4 different solutions to that equation. Okay, moving over to the sine squared, I'm first going to divide by 4. So I have the sine squared of x equals 1/4. Taking the square root, I get the sine of x is plus or minus the 1/2, which is the square root of 1/4. So again, I am looking for sine values that are both positive and negative 1/2. And that occurs in several different places. Sine values are your y values. So we've got some shorter angles to deal with here that don't go up as high. Those, of course, are pi over 6s. So the first one over there is pi over 6. Working our way around to the second one, we get 5 pi over 6. Those both have a sine value of positive 1/2. And then the negative 1/2 values occur at 7 pi over 6, and again, way over there at 11 pi over 6. And these are all in the interval 0 to 2 pi. Now notice if we actually had one that ended here, we would call it 0, and we would not call it 2 pi because of the interval notation with that being a square bracket and that being rounded off. Okay, a couple more without the calculator. This one has, I see, a tangent in both spots. And since that's the case, we may be able to factor, so let's go with that strategy. So the tangent of x times the square root of 2 times the cosine of x, and we need a minus 1 to hold the place for the minus tangent. And now it's factored. So we can set each factor equal to 0, just like we did with quadratics. Therefore, we have the tangent of x equaling 0, and also the square root of 2 times the cosine of x minus 1 equals 0. Tangent is slope, and where the slope is 0, that is at 0 itself, and also over at pi. And then doing this in one step, I add 1, divide by the square root of 2, which did not have to take a square root here. Therefore, I do not have plus or minus. I just need to know where is the cosine positive root 2 over 2. And that occurs at pi over 4, and down here in the fourth quadrant at 7 pi over 4. So my solutions are and 7 pi over 4. And now this one, I've got a mixture of sines and cosines, which is usually not pleasant, especially if I'm trying to factor. Don't have anything in common. So I'm going to use my Pythagorean identities to replace this sine squared with 1 minus the cosine squared. So I have 2 times 1 minus the cosine squared of x. Notice the parentheses in the substitution. 1 plus the cosine. Distribute 2 minus 2 cosine squared of x equals 1 plus the cosine of x. And I've got linear terms, I have constant terms, I have squared terms. Get everything on one side, set it equal to 0 so that we can factor and solve. want my 0 over here because I like my positive squared term. So 2 cosine squared of x plus cosine of x, and then subtracting that 2 over, I get a minus 1. Now I need to start recognizing this as something that can be factored. Trinomial there. So it's 2 times the cosine of x and cosine of x. That's the only way I'm going to get my first term. 1's have to come from 1 and 1. And I need a positive 1 for a middle term, and I need one sign that's positive and one that is negative. I'm going to put the plus here so that I get 2 cosine of x when I multiply, and a minus 1 cosine, so I have 2 minus 1 for my positive 1. Now we set those each equal to 0. Doing so, we get the cosine of x is equal to negative 1. Setting this factor equal to 0, I get the cosine of x equals positive 1 divided by 2. So we're looking for a cosine value of positive 1/2. And that means x coordinates of 1/2, so those are pi over 3's. So I have x equals pi over 3. And then going down to the bottom of the circle at 5 pi over 3. Thinking about these. Both have that same cosine value there, the x value. And a cosine of negative 1, that's an x coordinate of negative 1, that only happens at pi. So this time we only had 3 solutions instead of 4. Okay, now notice that we no longer have the 0 to 2 pi restriction. It is going to include some unit circle stuff, but we also want to include all coterminal angles. That simply means that we want to say any number of times around the circle, any number of revolutions. So if you wanted to go around the circle 4 or 5 times and then land in the same place, we're going to have to write our answer to satisfy that. We'll do that at the end. Alright, so this one I'm looking at this as being a quadratic, and then we've got all signs. That's really nice. So I'm going to start factoring. That's 2 times the sine of x. So 2 sine of x, and I need a sine of x. I need a 1 and a 1, and same sign, both positive, so those equal to 0. So this one we have setting that equal to 0, sine of x equals negative 1 divided by 2, and this one, the sine of x equals negative 1. Sine of x, negative 1, straight down at the bottom, so x equals 3 pi 2. Sine values being negative 1/2, y values of negative 1/2, those are pi over 6's, so this is x equals 7 pi over 6, and then again at 11 pi over 6. Now, to satisfy this, include all coterminal angles, we are going to say that it equals, for instance, 7 pi over 6, and we're going to say plus 2k pi. When you recognize the 2 pi, that's a rotation, an entire rotation in radians. That's how we get coterminal angles. And now we will further clarify by saying that k is going to be a member of the set of integers. So you can add or subtract any rotations that you want from that. We also have then 11 pi over 6 plus 2k pi. And x equals 3 pi over 2 plus or minus, it ends up being minus if you use a negative integer, 2k pi. So we have 3 solutions there, and the 2k pi is just saying you can go around as many times as you need to, but land in the same place. Okay, then moving on here to this sine squared and this cosine. usually not a good mix, so I will replace my sine squared with the Pythagorean identity. So 3 cosine of t, 2 times parentheses 1 minus cosine squared t, distribute. And now that I have distributed, I would like to get it all equal to 0, get my squared out in front there, so 2 cosine squared of t plus 3 cosine of t minus 2 equals 0. And to factor that, I'm going to have 2 cosine of t and a cosine of t. I'm going to need a 2 and a 1 positive, 1 negative. I need to get close to 4, so I'm going to do 2 times 2, get a 1 there. I need more positive, a little less negative, so there's my factoring. This one gets me cosine of t equals positive 1/2. That happens when the angle is going to be pi over 3, or at 5 pi over 3 down there in the fourth quadrant, because we have a positive 1/2 cosine value. And of course, both of those plus 2k pi. Now this one, the cosine of t equals negative 2. The cosine is never negative 2. The minimum cosine value that we have is negative 1. If you were to type inverse cosine of negative 2 in your calculator, it would say that there's an error, domain error. There is no such angle that has a cosine of negative 2. Therefore, this is a dead end. Technically, this one has no solution. Not that our entire solution has no solution, our entire equation. It's just that we're limited to these. This is, for all our purposes, a dead end. It doesn't do anything for us. Okay, now let's take a look at some of these using the calculator for sure. We'll look at it using the calculator and reasoning through, and then we'll kind of compare it to the cosine graphs that we looked at in last chapter. So when I type this in, I'm going to go and type in the inverse cosine of 0.75. I have already done this, so you may need to take a minute and pause and type these in and verify for yourself that you can handle these. When I type that in radian mode, I got that my radian measure was 0.723. Well, I'm supposed to be solving the equation from 0 to 2 pi, all the angles. So the first time around, I'm just going to get 0.723. I'm looking for a cosine value of 0.75. That is an x coordinate of 0.75. So that's the unit circle, that's 1, and I'm only going out 3/4 of the way. Well, that happens in 2 places. So I have an angle that goes here, and I have another angle that goes right there. See, that's why it's 2 angles here. The first one is simply the one I got on my calculator, 0.723. The other is the angle that starts here at 0, but it goes all the way around into the fourth quadrant and lands at that spot right there. Now, the 0.723 that we got is also sitting right here. You just reflect it over 0.723. And of course, it's negative, it goes this way. Well, that can help us get that angle that's almost all the way around. This, of course, would be 2 pi. So another solution that we have is to take 2 pi and back it up or subtract off the 0.723 radians that we have for the angle in the first quadrant, and that will leave us with 5.56. So there are my two solutions, 0.723 and 5.56. Those are for 0 to 2 pi. And then all angles, again, you're simply going to add plus 2k pi, where k has to be an integer. Now if we look at the graph and how it corresponds to that, we're looking at a 0.75 value. So right about in here, and notice that it only crosses in two places. That is right there and right there. This right there, remember this is pi, so that's about 3.14. 2 pi is 6.28. Therefore, our 0.723 fits in right there. It's very small. And this one is our 5.56 that we found earlier. That's a nice way to just verify and check your answer. Also, connection to our graphing. Now, tangent of x equaling 5, that means we're looking for an angle that has a slope value of positive 5. This one's going to look a little different. With the tangent value being 5, I did the inverse tangent of 5 on my calculator, and it tells me that it is 1.37 radians. So this angle right here is 1.37 radians, right there. I need to know the other angle that has that same slope value, so I'm going to have that angle start here, and this one also has a slope value of 5. And here's where we get our geometry back in here. This angle right here occurs again here. These are vertical angles made by the same two lines that intersect right there at the origin. And to come up with that angle measure, we are simply going to take the nearest axis, which is pi. This angle that's highlighted is also 1.37 radians, so our other value besides the first one the calculator told us is pi plus 1.37, which is approximately 4.515. So then looking at the related graph, that is 10. So we're going up 2, 4, 6, 8, 10. So 2, 4, 5. It's right in here. And that happens right there, just before pi over 2, which you can see on the first graph that we made. And also again, right there, just past pi, but right before 3 pi over 2. And it doesn't happen again, so we have got both of those. Okay, last equation on this section. Sine squared of x equals 0.4. Square root time, plus or minus. So the sine of x equals plus or minus about 0.632. Over. So that means I'm going to do my inverse sine. Sorry, I did the inverse sine, and that was 0.632. Sorry about that. When you take the square root of that and do the inverse sine, start that over again. What we're doing is taking the square root and square root of 0.4 over. Let's touch this. That's 0.632. So now we need to do the inverse sine of that. 0.685. So 0.685. Let's go back to that. So what we just found out was that x equals, we did our inverse sine with our square root of 0.4. Let's look at it again. I get it wrong. 0.685. 0.685. So notice, remember we were doing plus those. So we are looking at the angles that occur. The positive or negative sign value of that much happens here, right here, here and here. Okay, so what we have here is the radian measure of 0.685 radians. This angle is also coming up here at 0.685, and here is 0.685 radians, and so is this. So we have 4 different angle measures that we need to talk about. First of all is the one in the first quadrant that the calculator knows with inverse sine, which is simply 0.685 radians. Okay. Number two, we will calculate doing pi backed up 0.685, and I will leave you to that simple calculation. So being less than 3, of course. Then number 3, down here in the third quadrant, that's going to be pi plus 0.685. Again, calculation is yours. And number 4, we have pi, not 2 pi, not pi, but 2 pi here, closest axis. It's related to that angle. So 2 pi minus 0.685. And that will take care of the one in the fourth quadrant. So this will put connection. It may not have on your page. Here's sine squared. And we're looking for 1 that equals 0.4, and it happens in 1, 2, 3, 4 spots. Remember, right about here is pi, 6.28, there's your 2 pi. So you can see it happens once here in the first quadrant, and here's the first quadrant here, here's the second quadrant one here, and there's your third quadrant, and there's your fourth quadrant one. And those decimals should look pretty good if you've calculated those. They're should be pretty close to the ones that are down there. And that's equation solving.